You're listening to Electrician Live with your host, Paul Abernathy. Hey, everybody. Welcome to another episode of Electrician Live. My name is Paul Abernathy, your host, and welcome to today's podcast. Quick announcement. Again, remember, January 2020, more specifically January 4th, we're going to launch live. So hopefully you marked your calendars. We are going to be live on January 4th at 8 p.m. Central Standard Time. We're going to have a good slate of topics to talk about that you can call in. How do you call in? Make sure you download Skype on your cell phone, tablet, desktop, laptop, whatever you use, and get a free account. And you can call in using the call number Master the NEC. Okay, MasterThenec, all one word. That's the number to call in, or that's the ID to use to call into the show. And we will be broadcasting live at 8 p.m. Central Standard Time on January 4th. And again, we'll do it each week on Saturdays at 8 p.m. So, welcome to today's podcast. I had a request to just have a little chat about ground rods a little bit. And I had a question from one of our listeners who said that when I talk about, he said, we need more service grounding bonding, please, like meter ground rods. How many for that? And do we need a ground rod at the panel if we ground rod at the meter already and things like that? So this is for you, Carlos. I'm going to talk a little bit about ground rods and grounding and bonding. But we're going to talk ground rods in general since I really haven't done a topic specifically to ground rods. So we're going to talk ground rods. Now, a couple things we all know, okay, about ground rods. In accordance with the National Electrical Code, again, I'm in 2020 National Electrical Code, but none of this has changed from the 2017, so it's not shocking material for you. Under 250.52 A5, we have what's called rods and pipe electrodes. Now, we're talking about ground rods in this episode, so we're going to look at it. So the requirements is that the rod electrode shall not be less than 8 feet in length and shall consist of the following material. So when we're dealing with a ground rod, it's got to be a rod type electrode of stainless steel and copper or zinc coated steel, and it shall be at least 5/8 of an inch in diameter unless listed. Now, what does that mean? Well, 5/8 of an inch is what it would be required if it was non-listed. And if it's listed, it can be less than 5/8 in diameter, and they typically are. But what happens is they will consider them equivalent to 5/8 because they're listed. Okay, so this was a big stink that took place at NEMA, arguing back and forth. Everybody got involved in it, crying back and forth. Code standards panel, or Codes and Standards Committee and their high horse got involved, and everybody just back and forth, an argument, got kicked back around. The ground rod people weren't happy. Some people felt like they were being singled out. And anyway, the reason is a changing of a standard, the GR standard for ground rods, and not equating a ground rod that was listed but less than 5/8 is actually being 5/8. And of course, the standards all refer to 5/8. It got totally muddied. The reality of the code is, if it's listed, it can be less than 5/8. If it is like a half, okay, 1/2. Whereas if it is unlisted, then it has to be at least 5/8 because they have to have a certain level or a certain amount of diameter to it. And you put this into the earth, and it's going to allow lightning to dissipate into the earth through this electrode. Okay, so you're creating a grounding electrode system to stabilize voltage, to reduce the transient voltage from high power lines coming in contact with lower power lines getting sent to the earth, because utilities have rods and ground rods driven at their poles, and lightning strikes the system and it's trying to get down to the earth or vice versa back to the sky, and step leaders and all this kind of crap. At the end of the day, the ground rods have to be of a certain type of construction, okay? And we've established that. Now, there's a certain way that you have to install a ground rod. Now, if you have your code book, 250.53A starts to tell us, and we have an A, A1, A2, A3, A4, and A5, okay, that talks about it, different concepts. But the first one is talks about ground rod, pipes, and plates. And so we're going to specifically stick to rods, okay? Now, the first thing it says that a rod, pipe, and plate, we're dealing with rods, shall meet the requirements of 250, 53, A1 through A3. Okay, so A1 tells me that below the permanent moisture level. So if practicable, okay, argued term all out through the NEC experts, what's considered practicable, whatever you can say it, are not, right? And so, but it says where practicable, rod, pipe, or plate electrodes shall be embedded below the permanent moisture level. Rod, pipe, or plate electrodes shall be free from non-conductive coatings such as paints or enamels. Well, stands to reason you need that metal to earth contact. So, but a couple things that I chime in about that is that it makes it really clear that it's driven below, or we'll talk driven in a minute, but it needs to be below the permanent moisture level. Probably nobody out there literally does that. And so most people constitute that as being, as you'll see here in a little bit about how it's driven, they'll constitute that as being simply driven below the surface level of the earth. Okay. Although, again, it doesn't say permanent moisture level. Again, some people argue what the hell is that, permanent moisture level. But that's what the code says, first off. Secondly, it says, guess what? That you're going to have, if you have a single rod, you're going to supplement it. Okay? So, if I got one ground rod, I'm going to have to supplement with a second one. So, years ago, we would do one, and if it did meet 25 ohms or less, then we add a second one. Now it's telling you right off the bat, you need to, if you're going to have a ground rod, which is your grounding electrode system, that's it. Your one rod. That is your grounding electrode. You got to supplement it with another electrode. And it can be of the type from 250.52A2 through A8. Basically, I can supplement this with any of the other types of grounding electrodes except the metal underground water pipe, which has to be supplemented anyway. So I've got a bunch of different options to supplement. Now, I think between me and you, most of the time, if somebody's already driving a ground rod, they're going to supplement it with another damn ground rod. Makes sense, right? I mean, seems like that would be the case. Because, let's be honest with you, if you had a concrete case electrode there, the hell are you doing driving a ground rod? You don't need anything more than a concrete case electrode. So, again, so kind of unique in how this does this, but it lets you have any of the other electrodes if you want as your supplemental. It allows you to do it. Now, so that's it. Now, A3 talks about the electrode spacing. So that just reminds us that if I drive that original driven ground rod, now I have to supplement it, that it has to be at least not less than 6 feet apart from the original electrode. So the supplemental electrode, which is your other ground rod or your second ground rod, has to be at least 6 feet away from the first grounding electrode, which is the ground rod in our case. So that's where you get your 6 foot separation. Okay? We're all clear on that. Good. So those are the rules for the ground rod. Now we're going to talk about how you install that ground rod. Now, this might seem like old hat for people, but believe it or not, people still get this screwed up. So, first and foremost, you're required to drive that ground rod. If you drive that ground rod and you hit rock bottom, you hit earth, you're allowed to drive it at a 45-degree angle. It can't be any steeper than 45. That's the max. I drive it at a 45-degree angle. If I hit rock when I'm doing that, then and only then am I allowed to dig a trench that is at least 30 inches deep. And then I can lay the rods in that trench. Keeping in mind that the rods still have to be 6 feet apart. So that's a pretty damn long trench. You got an 8-foot rod, an 8-foot rod, and 6 foot. Okay? So that's a pretty good amount of distance that we're having to separate them, right? So I'm thinking you're going to have a 22-foot long trench just to make sure that these rods stay 6 feet apart. You probably don't have that much space on your job site. So here's what we run into, though. You have a basement that's being in a house, and you get out there, and they haven't backfilled yet, and they're waterproofing the basement. They got all this waterproofing stuff on the tar and all this kind of stuff. And so some electrician just wants to throw the rods in a trench right there because there's a gap there between the house and it's deep. So they're like, oh, I'll just stick it right there. That would be a violation. It's got to be driven. And only after you try to drive it, if you hit rock, can you go to 45. And only then if you hit rock can you go to the trench. So you can't just immediately jump to the trench. Now, there's another thing that people overlook. It requires it to be driven. If you have that gap there, I have seen people that literally take a ground rod and just stick it in the ground in that gap, and they say, you know what, the contractor will backfill around this, and eventually they'll backfill around the rod, and I'm good to go, and I don't have to drive it. Woo! I got away from driving a rod. That is not accurate. That is not what the code says. It says that it shall be driven to a depth. You don't get to go down the hierarchy until you've exhausted all of the options. You got to drive it. If that doesn't work, you go to a maximum of 45-degree angle. If that doesn't work, then and only then can you lay it in a trench. And you better hope that your trench is wide enough to make it happen, okay, or long enough to make it happen, all right? So that's kind of some things to think about when it comes to the ground rods. That's something that has to be taken into consideration. Now, next question. I get this from people. Paul, can I go from the meter to the ground rod or the ground rods? Can I go from the panel to the ground rods, say the grounded terminal bus? Can I go from the weatherhead where the grounded conductor, where it transitions from the service point? Can I go from any of that? And the question would be yes, yes, and yes. I could go from any of those. Now, again, it's going to be, probably subject to more degrees of damage than others, depending on where you run it. But at the end of the day, what does the code tell me? A 250.24 is real explicit in what it says. And I'm going to read it to you because there's still people that don't understand it. And so I want to make sure that we all are clear on what it says. Okay, so let me read it for you. I happen to have it handy. If I can, I did have it handy. Now I don't know where I had it. Hold on. Let me get it. Don't go away. All right, so 250.24, it says, and we're talking 250.24a, it says, a premise wiring system supplied by a grounded AC service shall have a grounding electroconductor connected to the grounded service conductor at each service in accordance with 250.24a1 through a5. You don't need to go any further than a1 because a1 says the grounding electroconductor connection shall be made at, quote, any accessible point from the load end of the overhead service conductors, service drop, underground service conductors, or service lateral to, including the terminal or bus to which the grounded service conductor is connected at the service disconnection means. So I can go from a spectrum all the way up at, let's say, the weatherhead point, or I can go all the way to the point where it's at the service disconnect. I can connect it to the grounding electrode system anywhere in there. Now, the other question they said, well, if I do it at the meter, can I do it at the panel? Well, if you want to do it twice, go for it, but you don't need to. You only need to do it at one point, okay? Can you do it at both? Yeah. Are you going to violate anything? No. Just multiple connections to the earth. It's not going to hurt anything, right? Remember, you're not trying to clear any overcurrent device, right? You're not creating parallel paths for that. You're not going to affect how an overcurrent device operates, okay? In fact, you want to get that current to earth as quick as possible, okay? So I don't have a problem with multiple locations for that as long as it's on the line side. In fact, the code allows us to make a lot of connections to bond equipment with the grounded conductor on the line side in 250.142. So I have no problem at all making that connection to the grounded conductor and then making that connection to the earth by what the code tells me to do. Can I do it in the meter? Absolutely. Can I do it in the service disconnect? Absolutely. Can I do it at the weatherhead? Absolutely. If you can make that connection to the grounded conductor, you go for it. Now, do inspectors have a problem with it in the meter? Yeah, they do. They don't like it. Some don't like it because they say, well, once that meter's in there, it's closed up and it's got that tag on it. It's not readily accessible. What the hell do you need to get it to it before? It's not like it's being checked. When's the last time you were called out to check the torqueness or tightness of the grounding electroconductor at the terminal? Come on, man. The code allows me to do it. So I hate it when people impose their own will. The code says I can do it. If I want to do it in a meter, that's probably the best place to do it because at least it keeps it outside. Now, with the 2020 code change, it's going to require an outside service disconnection mean labeled as a emergency disconnect now. I think one of the concepts here, or service disconnect, or I can't remember what we're calling it. It's almost like a brain fart there. It's emergency disconnect. So it's for the first responders, and that's what it's called. So we have this new rule, 230.85, that requires it for 1 and 2 family, okay? So in this case, you're already going to be out there, so that's pretty much the logical place that you're going to go to your grounding electrode system, okay? I mean, that's, for the most part, that's what's going to happen. All right, now, let's kind of keep moving forward here. So now, we established that. So let's talk about sizing a grounding electrode conductor. Now, depending on where you go from, whether it's from the meter, whether it's from the panel, whether it's from the weatherhead, whatever you're making that connection, from the trough on the lateral that comes up into it, maybe a trough before it splits off, or however you're going to make that connection to the grounding conductor on the supply side of the service disconnection mean, or within the service disconnection mean, you're making that connection to the grounded conductor, okay? Now, how do you size that? Well, we're all probably familiar with 250.66. There's a table, right? And then there's these A, B, and C. So since we're only going to deal with rods, we're going to talk about the table in full spectrum, and then we're going to talk about 250.66A, which is just dealing with the rod. Of course, it does pipe and plate as well, but we're just going to talk rods because that's what I was asked to talk about today. All right, so we got the ground rod, and another thing before I go further. The grounding electrode conductor that goes from, let's say, the panel's grounded neutral connection all the way down to a ground rod, that is the grounding electrode conductor. Now, if we go by the rules, it says that we have to supplement a single ground rod with an additional electrode, and in our case, we're just going to use another ground rod. They have to be 6 feet apart. We established that. The grounding electrode conductor actually stops, theoretically, at that first ground rod. Remember, because the second one is the supplemental. Okay, together they act as a full grounding electrode system, but that's a supplemental. The first ground rod was the one that constitutes the grounding electrode. And of course, you had to add a supplement. But that grounding electrode conductor is run unbroken to that first ground rod. Now, it can be irreversible crimped or it could be CAD welded application if there's a splice that's necessary. But other than that, it really can't be... it's got to be continuous, okay, to that first ground rod, but not to the second one. That is a bonding jumper to the second one. So if I come to the ground rod and I have a single acorn clamp, I can't stick 2 6 gauges underneath it. And we'll talk 6 gauge and I'll tell you sizing in a minute. We can't do 2 of them underneath it. I could put 2 separate ground clamps on one ground rod, and so the grounding electrode conductor goes to the first one, and then from that first rod to the second one, that's called a bonding jumper, and it doesn't have to be any larger than the grounding electrode conductor that was run to the first one, okay? So in this case, say it's 6 gauge copper to the first one, then it's 6 gauge copper to the second one. You got me? All right, it doesn't have to be larger than that. Now, could it be smaller than a 6? Absolutely, if it's a smaller service. It could result in being smaller by using the table. So remember, that's a permissive rule in 250.66A that says it doesn't have to be larger than 6. But could it be smaller than a 6? Absolutely. Because I can also utilize table 250.66, and you'll notice that it's 2 gauge and smaller. If it's a 100 amp service, for example, it's 2 gauge and smaller, then it could be an 8 copper. Now, the difference is that 8 copper, you're going to have to protect it against physical damage inside of some type of protection, okay, Schedule 80 PVC or whatnot. And heaven forbid you use a ferrous raceway as protection, because then you're going to have to bond that ferrous raceway to both ends of that grounding electrode conductor, but we won't go into that. So, yes, can it be smaller than 6? Absolutely it can be. But it doesn't have to be larger than 6, and if you go to 6, then you don't have the same protection requirements. So that's why you typically see a 6 running down the side of the wall, following the contours of the building and then over in the ground, and nothing requires that to be buried, by the way. But you want to protect it from physical damage, so most people will scrape away the earth and bury it. And remember, the rod needs to be driven, okay? So at that case, some people clear it away, but it's not required to be buried. That grounding electrode conductor isn't required. Okay, some people think it is, but it's not. All right, now, so I just wanted to establish that before I moved further into what we're talking about. All right, so now we've established the separation. We're running the wires down to conductors down to it. We established where we can make that connection. Now let's talk a little bit about sizing. We talked about. So we're stuck with this table called 250.66. Now, years ago, this table was used for a lot. Sizing grounded conductors, supply side bonding jumpers, system bonding jumpers. None of that is done with table 250.66 anymore at all. That's using 250.102C. Okay, and if you haven't seen my video on that, go watch my video on our YouTube channel. That's youtube.com/master the NEC and watch our videos. I do an extensive overview of all of those topics and explains it in a lot of detail. Okay, so this table is just for the grounding electrode conductor, and that is it, period. All right, now, talking ground rods. Immediately, we're going to go to 250.66. And 250.66 says the following. Let me read this to you because you really need to understand this. It says, size of alternating current grounding electrode conductors. It says the size of the grounding electrode conductor at the service at each building or structure where supplied by a feeder and branch circuit or at a separately derived system of a grounded or ungrounded AC system shall not be less than given in table 250.66, except as permitted in 250.66 A through C. So right there, when I get people ask me, what permits me to use a 6 and not have to be larger than a 6 copper, let's say, to a ground rod? That right there. Now, if you want to size it based on this table, like we said, if it's a 100 amp service and you want to have an 8 AWG to your grounding electrode conductor, then you're using the table. You're not using A under 250.66. But again, most people are going to have a consistent 6 gauge in their truck, and that's what they're going to use. But you need to understand that A, B, and C are permitted, not required. They're permitted. Could I just use the table and be done with it? Yeah, I could if I wanted to. All right? Okay. Just wanted to make sure we're all clear on that. You'll also notice that in this table that the grounding electrode conductors do not get any larger than 3/0 copper or 250 kc mil aluminum. Why? Because the grounding electrode conductors never have to be larger than a 3/0 copper or 250 kc mil aluminum. And that's it. That's the largest grounding electrode conductor that you're required to have. Okay? Now, I get asked this question a lot. What about an engineer that specifies a 4/0 or a 250 kc mil copper to ground rods? My response is, if that's the engineer is what they want, then you do what the engineer wants. But that's not what the code says. So you can either argue it, or you can let the engineer or let the company that you're bidding the work for pay for you to do the CAD welding to a rod if you want. I see it all the time. Again, it's going above the code. Remember that the National Electrical Code is a minimum standard. For some reason, that engineer wants it to be larger. They have some knowledge that's been passed down by Tesla for some reason, and they want it to be larger. Or maybe, in all fairness, maybe you're doing something that's not a normal residence. That would be crazy. But if you're doing something like a satellite tower or something, and it's really prone to a lot of lightning strikes, then maybe the engineers have done some testing and they want the ground rods to be 10 foot long. They want them to be in a triad pattern. They want it to be 500 kc mil run to each one, or whatever they want. To just do what they want. Okay, but you need to make sure before you bid that job that, one, you're able to do CAD welds, and two, you have them available and you know how to use them. And then let your project pay for them if you don't have them. Okay, but when you're dealing with the everyday electrician that does normal construction, normal commercial buildings, or normal 1 and 2 family or dwelling type, they're not going to have a CAD weld. They're just typically not. And if you say I'm full of crap, you're full of crap, because I know plenty of electricians who don't have CAD weld systems. I never had a CAD weld. I never, ever. And I did some big projects. And when it was called for, then I would either get one from somebody I knew and borrow it, but I never invested in one because I didn't do enough jobs that required it. Usually I could tell them and say, do you know, plus I didn't do hot towers either. I said, do you know that the code only requires this size? And the engineer would say, well, just submit a change order for it and I'll sign off on it. So I would submit it and he would sign off on it, and I'd just do it based on the minimum standard of the NEC. Not all engineers will push back, okay? They're not code experts. They design stuff. So again, you be fair with them, they'll be fair with you. I'm getting way off topic. So let's get back. So so at the end of the day, it doesn't need to be larger than a 3/0 on anything that's over 1100 kc mil copper or 1750 aluminum. That's 1,100,000 circular mils or 1,750,000 circular mils for aluminum. Okay, the grounding electrode conductor does not have to be larger than that. Okay, all right. So we're clear with that. Now, let's talk about some scenarios now. If I've got a 200 amp service and I'm going to go to ground rods, and we already established that I need 2 ground rods. Unless I can prove one is 25 ohms or less, I got to go with 2, and it got to be 6 feet apart. Okay, and that's assuming, again, we're talking about nothing but ground rods. Okay, there's no other grounding electrode present. This is it. Okay, none of them are available. All I've got is ground rods. Okay, let's not make this more confusing than it needs to be. All right, so I'm going to go to 250.66A, and I'm going to run a 6-gauge copper typically from my service disconnect to grounded terminal bus. I'm going to run it out and down, and I'm going to run it over to my ground rod. Now, typically, I'm probably going to loop it through and continue it on to the second one. Not that I have to. I can break it at the first one. Again, remember, that's a bonding jumper, but I'm saving a clamp. Now, you're probably saying, well, Paul, that's what, $2? I'm like, I'm just saying that's normally what I did. I'm not saying it's right or wrong. I'm just saying it's what I did. But it has absolutely nothing to do with the concept of being unbroken, because it can be broken from the first electrode to the second electrode. Okay? That's just a bonding jumper. Okay? All right. So anyway, that was my practice. All right? So I would utilize 250.66A and do that. Now, it used to be a term in there called the sole connection, and that has been removed from the National Electrical Code. Basically, it's talking about daisy chaining. So that means that I can go use a 6-gauge under the guidance of 250.66A, means that I can go, I'm going to give you this example. I can go from the panel to a ground rod, and then I could go from the ground rod to a plate or pipe electrode, again, 6 feet away, and it wouldn't have to be larger than a 6 because it's of the same class that is in 250.66A. However, I can't go with that 6 down to a ground rod and continue on to another type of electrode that would require a larger grounding electroconductor. Okay, that would defeat the daisy chain allowance of 250.66. So as long as I'm looping those of the same class that's listed in 250.66A, then I don't have to be larger than a 6. Okay, so I can't, for example, go with a 6-gauge down to a ground rod and then in 6 and then jump from there up to a concrete encased electrode with a 4-gauge, because that's the maximum required size. I mean, it doesn't have to be larger than a 4-gauge copper for a concrete encased electrode under 250.66B. Okay, so I can't do that because I'd be going up in size. All right, you get me? Okay, so I can't go up. Now, can I daisy chain down? Sure. So can I go with a 4-gauge to the ground rod, and then from the ground rod to, let's say, a concrete encased electrode with a 4? Okay, from there on to, absolutely, because I went with a 4 to the ground rod. Okay, and I'm not going down in size. I'm oversizing to the ground rod, to be honest with you. Okay, so that's a concept. Okay, but then again, that wouldn't be utilizing 250.66A to that ground rod. Okay, you get me? Because it's not connecting from the ground rod as the sole connection we used to say. It's going from one ground rod to another type of electrode that requires a larger grounding electroconductor. So that means that 250.66A goes out the window. Now, I happen to be using 250.66B, which is a 4-gauge to the concrete encased electrode, and the ground rod just simply got in the way, if you so to speak. Okay? But I'm most certainly allowed to daisy chain. Okay? And just got to remember those little rules is that you can always go bigger and go smaller. You just can't go smaller and go bigger. All right? So let's get back to ground rods. So the next thing I get asked by people is, what if I have a service overhead coming down to a wireway, and underneath that wireway I've got 6 disconnects, and those are the disconnects, service disconnects for a 6-unit strip building. And they're 2-hour rated walls, so it's one building. So I have one service, okay, and I have 6 disconnects, and they're grouped in one location. All that's good. Let's say let's just kind of go with me here. Now, I have 2 ground rods driven. I have multiple ways that I can make the connections to these ground rods. All right, multiple ways that I can go to the ground rod. Now, could I go out of each one of these service disconnects and go to that ground rods? Absolutely. Absolutely. That would be an allowance that I could do. And so that is given to us under 250.64D, and the option is D2. And that's called an individual grounding electroconductor. So I can run it individually between the grounding electrode system, and I can run it to from the ground rods straight up to the grounded terminal bus inside of the service system. I mean, that's my options, okay? That's one that I could utilize, okay? The next option that is probably the most common is, okay, so, and again, if those were ground rods, it wouldn't have to be larger than a 6. It doesn't have to be larger than a 6, okay? And that gets kind of messy. I got 6 separate grounding electroconductors. How about this? Can I run one from the ground rods up underneath all 6 of those disconnects and now do taps from those disconnects down to that common grounding electrode conductor? Now here's where some confusion starts, okay? All right, so is the answer to that is absolutely yes. And it's again 250.64D, but in this case it's D1. And it's called common grounding electroconductor and taps. And here's where there's some confusion that people have. Now remember what I said. It doesn't matter if I'm using ground rods. It doesn't have to be larger than a 6. Period. But some people will read this rule wrong, and they'll actually require that common grounding electroconductor to be something like a 500 kc mil, and all the tap conductors coming out of it are a 6 gauge, and you're sitting there shaking your head. What are you doing? Why would you do that? And then it results in you having to have a larger conductor that goes to the ground rods. And remember, the ground rods can only handle so much anyway, okay? So it gets confusing to a lot of people. So let's look at what it says in 250.64D1. Okay, so what it says is, it says in 250.64D says, and I'm going to skip down to the most important part. It says the common grounding electroconductor shall be sized in accordance with 250.66 based on the sum of the circular mill area of the largest ungrounded conductors of each set of conductors that supply the disconnection means. Okay, so now if I had an application where I had multiple sets coming in, and then I would take the largest conductor of each set, literally add them together, treat it like a single conductor, then I would go to 250.66 and I would size it. Okay, we got to remember something. And that's true for any time that you would use the actual table 250.66, because see, this sends you to 250.66. It doesn't send you to the table. 250.66 is what sends you to the table. So this sends you to the allowance in 250.66 based on the sum of the largest circular mill of the largest ungrounded conductors of each set of conductors that supplies the disconnection means. So if I have 4 sets of 500 kc mil coming in for this service, okay, and I'm going to make this connection, the common grounding electroconductor would be based on, if it's 4 sets of 500, that would be 500, 500, 500, 500. That's 2,000 circular mil. Or 2 million circular mil, that's 2,000 kc mil, 2 million circular mil. If that's the case, then that's going to be over 1,100. Then it wouldn't be required to be any larger than a 3/0 copper anyway. You with me? However, we know that we're using ground rods. So when you go to 250.66, you'll notice the allowance to use 250.66A. We're dealing with ground rods, people. So this is a big confusion. This is where I have actually seen ground rods at a service, and it's been as large as a 2,000 amp service, and I have literally seen multiple sets that are utilizing this common grounding electrode rule, and they literally have something like a 250 kc mil running underneath it, but the tap conductors, which we're going to talk about in a minute, are only 6 gauge, and they tap to it. Again, it's another concept of trying to put 20 pounds of crap in a 5-pound bag. They're ground rods, folks. That's all they can handle. That's it. All right, that's it. So in the concept of it, if I'm allowed to take nothing larger than a 6 to a ground rod, even if I have multiple services and I have a common grounding electroconductor, then that common grounding electroconductor doesn't have to be larger than the conductor that's required to be run to the ground rods, which is a 6. Now, if I'm doing a water pipe ground or an in-ground support steel or one of those other listed means, then I've got to use the table. And I've got parallel sets. Then this is going to be required to use this. And I just showed you how you add up the sum. I get it. But if you're doing ground rods only, remember, 250.66a is a permissive that says, guess what? Doesn't need to be larger than a 6. Well, what about that common one? It still doesn't need to be larger than a 6. It doesn't. And this is where the people will get confused on it. It literally doesn't have to be larger than a 6. It can't handle any more than it can handle. Okay, they're ground rods, for gosh sakes. Okay, anyway. Okay, lightning doesn't care, by the way. Okay, it doesn't care how many paths it's got or what size it is. It's going to strike, and it is what it is. All right. So how come it's okay to go from an individual one to a ground rod and only have to be 6, but yet if I do a common, then for some notion that common grounding electroconductor has got to be so much larger because people read this rule and think you got to take the sum. What they don't understand is it sends you to 250.66. Once you get to 250.66, you're able to use the allowances of 250.66a, b, and c accordingly. Okay? Should not be that complicated, but people do get that complicated. All right, anyway. So now let's talk about those taps. So now we've got those ground rods. And remember, it doesn't matter what the ampacities is. So at this point, I wouldn't need to do anything else. I could just say that those taps that come out of each enclosure, each disconnect, that connect onto the common grounding electroconductor doesn't have to be larger than a 6 either, right? But let's read it and see what it says. It says, the grounding electrode conductor tap, and again, that's what's coming out of each one of those 6 disconnects down to that common grounding electroconductor, shall extend to the inside of each disconnecting means enclosure. So it means to go up into each disconnect from the grounding electroconductor, common one, up, straight up. Those taps have to go into the disconnection means. Okay. It says, the grounding electroconductor taps shall be sized in accordance with 250.66, again, for the largest service entrance or feeder conductor serving the individual enclosure. So we're only sizing it based on the conductors that are feeding that enclosure. Well, at the end of the day, once we go back to 250.66, we know that it says, oh, by the way, you got ground rods? Guess what? You can use 250.66a, my friend. Sometimes we really do overthink things in this industry. Okay, so it's done. All right, so now the reason we do this, because I could have maybe these are all not 200 amps. Maybe they're all just 100 amp. And so if that's the case, I go over to 250.66. I could go, it doesn't have to be larger than a 6, but because it's 100 amp, I might be able to get away with it being an 8 gauge. And of course, as long as I protect it, then I can run that 8 gauge. But most people, again, are going to use 6 because you don't have to protect it against physical damage the same way that you would an 8 gauge. Okay? So that's the concept. Now, where do I get that from? You're asking me where I get that from? That's under 250.64 B3. It says smaller than 6. It says grounding electroconductors smaller than a 6 shall be protected by RMC, IMC, Schedule 80 PVC, and it gives you RTRC, XW, as well as EMT. Okay? Yes, EMT is also. And it also allows for cable armor. They do make a 8 gauge with a cable armor over it that is utilized for this specific purpose of the grounding electrodes. Okay? They do make it. Okay? So, anyway, those are your allowances. So, if you don't want to do that, then just make it 6 gauge and run it with the surface of the building, and and that's why most people do that. Okay, if you didn't know that. Okay, in case you weren't aware of that. Now, and when I say cable armor, guys, for smaller than 6, that's a specialty made type of 8 gauge solid that's inside of an armor that looks like MC, but it's not MC. Okay, it's made specifically for these applications. All right, and it covers under the grounding and components UL standard. Okay. Anyway, all right. So that's the rules that we're talking about. Okay, and so most people are just going to say, well, "Look, I'm just going to do it in a 6 gauge and be done with it." So I thought that. Now, there's a third one that we got to be in. That's called a common location. So now we're going to talk about 250.64 D3 called common location. So in this case, the one I just talked about was where you're coming out of the disconnects and you're coming to a common grounding electroconductor underneath them, and then it goes from there and it carries on to the grounding electrodes. Here you're coming out a common location, like in a wireway. and you're coming out of that wireway, it hasn't yet gone through maybe the meters, it yet hasn't gone through the disconnects yet, you're at a common location. And here's what the code says. The code says, common locations. It says a grounding electrode conductor shall be connected in a wireway or other accessible enclosure on the supply side of the disconnection means to one or more of the following as applicable. So I can make it a connection to the grounded service conductor in that wireway, come straight out of there, and then I can go straight down to the ground rods if I want, right? I can make that connection. The next one, it says the equipment grounded conductor installed with the feeders. Okay, that's when you're doing to a feeder to a remote building, for example. That application is where you make that connection. Again, you're going to a remote building under 250.32. We want to have, also remembering 250.24A5, we want to have a separation between the grounded and grounding. So this is just saying that that common location can be made to that equipment grounded conductor at that remote panel where a feeder is feeding it, because there's supposed to be that separation anyway. So that's where you make the connection there. And of course, supply side bonding jumper as well. You can make a connection to that. All right. Now, sizing here. It says the connection shall be made with exothermic welding or a connector listed for grounding and bonding equipment. A split bolt, for example, is listed for grounding and bonding, but verify that the split bolt you're using is listed for grounding and bonding. Okay. It says the grounding electroconductor shall be sized in accordance with 250.66 based on the service entrance or feeder conductors at the common location where the connection is made. Okay, so in our case, if it's an overhead, it's coming overhead into a wireway, and then it's going to drop out of the wireway into the meters and then down to the disconnects. If it's two sets of 500 kc mil that's coming down from the weatherhead into the wireway, then I'm going to base it on the two ratios. So it's 500 in this one, 500 in this one, because it's two sets of 500. You only take one phase or one leg, and so it's 500, so it's 1,000 kc mils. So if that's the case, if I was doing a water pipe ground, or if I was doing an in-ground steel, or something like that, then I'm going to go to table 250.66 and size it for 1,000 kc mil. In this case, it would be a 2-aught copper. However, if it's also ground rods, it's sending me to 250.66. Again, I can utilize 250.66A. Then it only needs to be 6 gauge. It doesn't have to be larger than a 6 gauge to those ground rods. You see how this works? Okay, that's the power of 250.66 A, B, and C. They're not really listed as exceptions, except for the fact in 250.66 it says that you use table 250.66 except as permitted. So it sounds like an exception to me, but it's not written like we normally would see an exception written, right? Kind of how that language goes. So hopefully I've covered most everything that I can think of about ground rods, and those connections can be at multiple locations on the supply side. Not a big deal. Hopefully you got something out of that. If I left something out you wanted me to go into, those are just the reasons you can make those connections. Please remember, it does not have to be continuous, unbroken to the first ground rod all the way through that to the second ground rod. You can do it if you want to, but the grounding electro system stops at the first one. The second one is simply the supplemental requirement that's required in the code for you to supplement that first one. All right? And that is listed in 250.53A2, okay, where you have to supplement it, okay? So don't let it get confused. You can break it. Doesn't have to be continuous, but if you want to save a clamp, make it continuous and you get away with clamp. Anyway, that's all I got, folks. I tried to keep it as short as I can. Again, it seems like I still rambled to 45 minutes. I'll remind you, if you made it this far, that we are going live on January 4th at 8 p.m. Central Standard Time. Go to the website, electricianlive.com, and get more details. And hope to see you then. Until next time, folks, stay safe. God bless. You've been listening to Electrician Live with your host, Paul